A highway engineer once investigated a strange pattern. Accidents kept happening on the same stretch of road, same time of day, same direction, same type of crash. The vehicles weren't faulty, the drivers weren't careless. The real culprit? A poorly designed curve that forced drivers into a dangerous combination of low visibility and sudden steering correction. One geometric mistake, hundreds of lives affected. That's the real weight of transportation engineering. One wrong angle, one wrong slope, one wrong radius can ripple across an entire city. All lectures in this Civil Engineering Master Series are available on the Learning Studio for students who want fast, clean, exam-ready concepts. What transportation engineering actually covers? It's the science of planning, designing, operating, and maintaining transportation systems. But for your exams, the spotlight is mainly on highway engineering, where every design decision revolves around one question: how do we move people safely and efficiently? 2. Road geometry, geometric design. Road geometry determines whether a driver feels safe or panicked. Core components you must know: cross-section elements, carriageway width, shoulders, medians. Sight distances, SSD and OSD, foundational exam topics. Horizontal curves, radius, superelevation, transition curves. This is where most accident case studies come from. Vertical curves, summit curves for visibility, valley curves for comfort. A road with bad geometry is basically an engineered accident waiting to happen. 3. Traffic engineering essentials. Traffic is not random, it follows predictable relationships. You must understand traffic volume, vehicles hour, used for capacity analysis. Speed studies. 85th percentile speed is the backbone of geometric design. Flow speed density relationship. Q equals KV. If you don't master this, traffic analysis will never make sense. Level of service, AF, used to judge how smooth or jammed a roadway is. These concepts form almost 40 to 50% of typical transportation exam papers. 4. Pavement types. The surface you drive on is not random. It's engineered for load, climate, and lifespan. Flexible pavements, asphalt. Cheaper, easier to repair. More common in developing regions. Rigid pavements, concrete, higher initial cost, long service life. Preferred for expressways and airports. Expect a short note, difference table, or design step question from here. 5. Why it matters. Every road accident analysis, traffic jam, maintenance plan, and expansion project links back to these fundamentals. Understanding this subject makes you realize transportation engineering isn't about roads, it's about human safety. Next, we'll break down pavement design and the logic behind choosing flexible versus rigid in real projects. Make sure to follow the Learning Studio for crisp, exam-focused civil engineering lectures with zero fluff.